So, good morning, students. So, let us again we will discuss a topic on our channel, which is Educator, which is a finite automata. See, engineering students, they must be aware of automata. Let me give a brief introduction of automata. Such system where energy is transformed from energy or maybe materials or information are transformed from one form to another without direct participation of man. Very simple automata. And this automata is generally we study in computer science a discrete automata. Okay, consisting a simple model of automata consisting of inputs and consisting of outputs. Okay, like inputs, there could be different inputs like I1, I2, and different outputs like O1, O2. And during this, the discrete automata undergoes certain state changes, let it be Q1, Q2, and Qn. These are the different states under which this automata can be. So we have inputs, outputs, and the states. And there is a transition function called delta, which is which takes from current state and current input alphabet. Input alphabet, as you are seeing here, two inputs are there, I1 and I2. The input alphabet will be consisting of these two inputs, I1 and I2. And this goes to the Q cross sigma. It goes to mapping to Q, means on the current state and current input symbol, it goes to the next state. Okay, so this is delta, which is a transition function. Okay, sigma here is the input alphabet, Q is the set of states. So these states Q1, Q2, Qn, these come under this set of states Q. Okay, now in general, an automata can have outputs also, and it can be without output also. For example, deterministic finite automata, which is one of the type of finite automata. It consists of states, and state itself contains the memory. So there is no different outputs in this. The only acceptability and the non-acceptability of strings is checked in deterministic finite automata and the non-deterministic finite automata. Difference between DFA and NFA is simply that DFA has transition, finite definite transition from current state and current input. We have a transition to one state only, while in case of NDFA, which is a non-deterministic finite automata, it could be in more than one states. More than one state means it's mapping from Q cross sigma to 2 raised to the power q, which is a set of subset of the state of q, because it can have moved to more than one state in case of non-deterministic finite automata from a given state. Now let us consider again let us tell me what are the 5 tuples of a DFA: q, sigma, delta, q naught, and f. Let us understand these tuples. Q is the set of states, sigma is the set of input alphabet, delta is the transition function that we discussed here, q naught is the initial state, and f is the final state. Actually, on the input tape, suppose you have an input tape and you write the string as a, b, a. Suppose this is the input string, and these are blank symbols, and let us say we have a automata which is reading some symbol a at any time under the state, let us say q1. Then on reading the current input symbol under this read head, generally this head is read head, and but in case of Turing machines, it could read as well as write on this input tape. This is the input tape. Okay, so on reading the current symbol in the input tape under the current state, let us say q1, it makes a transition to the next state, makes a transition to the next state by this, which is defined by this delta function. The delta function tells me on the current state in the current input symbol which state it will move on to. Okay, so this is generally in a case of DFA and NFA. This read write head can only read symbols, and it moves only in one direction, that is from left to right, and until it finishes onto the last symbol of the input string, that is a. And if it ends up on this input alphabet a, if it ends up in the final state, this string is accepted, otherwise this string is rejected. Now let us make a deterministic finite automata for a given state, and let me introduce to us very interesting trick of deterministic finite automata in in deterministic finite automata to design any language. Okay, so let us discuss one DFA for that. We will take one example of a DFA, and then we will try to construct a DFA for that example. And for that example, we will design the set of states Q. We will design the sigma input alphabet, delta transition function, Q naught initial state, and final state. Let us understand the construction of DFA, and let us understand what is the trick in the DFA designing. Okay, so I am running this off. Now let us design a DFA over sigma equals to AB accepting odd number of A's and even number of B's. Okay, now let us design for this. Now understand this. See, we have 5 tuples Q, sigma, delta, Q naught, F. Input alphabet is clear. Alphabet, the word alphabet comes from, for example, you have an English alphabet which consists of 26 letters. So it is a subset of that. It is sigma, which consists of, we are designing an input alphabet which we have 2 symbols only, A and B. Okay, now according to this condition where it is saying that accept odd number of A's and even number of B's, let us understand how many states the DFA could have. See, if it accepts odd number of A's, even number of B's. Now, A's can be in odd or the even configuration. Similarly, B's can also be in the even or odd configuration. So we have 2 states for A and 2 states for B. And since the DFA is to be designed for this for the strings which takes the states of A's and B's simultaneously, so total number of states that we will make for A and B will be 2 by 2. Means 2 states for A, 2 states for B. So simultaneously A and B could be in 4 configurations. Now let us understand what these 4 configurations would be. So I am rubbing this off, and let me design the machine directly. Okay. Now the 4 states would be even configuration of A, even configuration of B, even configuration of A, odd configuration of B, odd configuration of A, and even configuration of B, and odd configuration of A and odd configuration of B. These could be the only 4 states possible for this automata, because we are seeing, suppose had I been seeing only the configuration of only A's, then there could be 2 states only, even A and odd B. But here there are 2 symbols A and B, and we are checking DFA for both the symbols A and B. So A can be in even or odd state, B can be in even or odd state. Simultaneously there could be 2 into 2, 4 states for configuration of A's and B's. Now let us decide what could be the initial state. See, initial state will be one where we would be standing when we have not reached any input, we have not received any input, and that would be epsilon state, which has no A's and no B's. Now no A's means count of A is 0, no B's is count of B's is 0. So both are in 0 count. So which configuration will it represent? Even configuration of A and even configuration of B. Means this would be the initial state. We would be standing without consuming any input symbol. Now the trick is you have to make all the 4 states for this DFA, all the 4 situations that this DFA could be in. Okay, decided the initial state. Now according to the acceptability, see, remember the problem, odd number of A and even number of B's has to be accepted by this DFA. So this would be the final state, which we have indicated by a concentric circle, and this arrow pointing towards the state will indicate that is the initial state. Okay, let us number these states as Q0, Q1, Q2, Q8. Okay, now the thing is simple. We have designed all the machines, decided the initial and final states. Let us make the transitions from these states. Now there are only 2 inputs, A and B. So these states will make transition on these 2 inputs only, either A, means not either A and B. So let us make transition from this initial state on the symbol A. Now, this initial state has even configuration of A and even configuration of B. Suppose I add A to it. So which configuration it will go? Let us take one sample string A, B, B. This string is in this configuration? Yes, it is in this configuration. Two A's and two B's. Even count of A, even count of B. So it is in this state, even A and even B. Now let us take, we consume one more A. So on receiving one more A count will become odd and B count will become even. So it will go to the odd configuration of A and even configuration of B, which is state, this one state B. So A, it will go on to this state. Okay. Now let us take the transition on B. Suppose instead of A, I add B to it. So what happens? The configuration of A will remains even, but configuration of B becomes odd. So it will go to even A and odd B. So this will be the transition. Okay. Now you might have guessed this, that when you receive a, then you alternate the configuration of A. For example, if you are have even A, you go to odd A. If you are in odd A, you go to even B. Same is the case for B. If you are in even B state, you go to odd B. If you are in odd B, you go to even B. Now let us make the transitions on other states also in A and B. This states A and B transition are over. Now let us understand this state. This state has even A and odd B. Let us take one sample string A, B. Even A, two A's are there and one B is there. So A are in even configuration, B is in odd configuration. Now let us take, we received A. So I am consuming one A. The state of A becomes odd and B remains as it is odd, जो कि पहले से ही था. So we make a transition from this state to this one state on A, because count of A becomes odd and B remains as it is because we have not received any B. So odd A, odd B. Similarly, on encountering B, even A, B, suppose we have received B, so A count remains even because we have not received any A, so A count is not affected. Only receiving B will affect the count of B and making it to even B. So the state will be even A, even B, which is initial state. So it's now this state A and B transitions are over. Let us come on to this state. Now, if you have grasped the concept, then you would have understood that we alternate the configuration of the individual symbols. Now, odd A, odd B. Let us take one more example, one sample string of this configuration A, B. A count is 1, B count is 1. So, odd A, odd B. Now, let us take, we received A. So, on receiving A count becomes even and B remains odd. So it goes to the state even A, odd B. So this one state. Now B transition, it's easy now. On B transition, A will remain in the odd configuration and B will switch to the even configuration. So we will come on to odd A, even B. So this will be the transition. Okay. Now this state transitions are also over. So now decide this state transition also. On A, this state, which is the final state, on symbol A, it will go to even A, even B, means this state. And on B, encountering B, odd A, odd B. Odd B means this one. Now all the transitions of all the states are over. Your DFA is designed. Okay, DFA is designed. So this trick works very well in case of any DFA. You remember, if you able to decide the number of states that a DFA could have according to the language of the DFA, then your work is more than half is over. And deciding then what would be the initial state and final state according to the language, and then making the transitions on the input alphabet from these states, from these individual states. So you are done. So this is the one trick in designing a DFA. Now let us check the acceptability or the non-acceptability of a string by this automata. Consider a string, random string, B, A, B, A, B. Now, according to the situation, it contains even number of B's and even number of A's and odd number of B's. This should not be accepted. Let us check through this automata. This would be accepted or not. Let us start from the initial state, which is even A, even B. On encountering first symbol, that is B, it will go to this state, even A, odd B. Okay. Now, on encountering again A, it will go to state odd A, odd B. Now, another symbol B. On processing B, it will go to odd A, even B. Okay. Now on processing symbol A, it will go to even A, even B. This is not the accepting state, so this string will not be accepted. Let us take one string which should be accepted by this automata. Accepting string will be the one which reach in this state, which is odd A, even B. Odd A, even B means A, B, A, and even B. So this should be accepted. Let us check whether this string is being accepted by this automata or not. We start from the initial state Q0. Current input symbol is A. Current input symbol is A. So on processing A from this current input state Q0, which is the initial state, we go to the state odd A, even B, which is state number QF. So we come on to the state number QF, and the input string is input pointer is moved ahead onto the symbol F. So we are not in now in state QF. Now on from this state QF, we have to process B. On processing B, we go to the state Q2, which is odd A, odd B. So we move the input pointer one position ahead, and the state is now Q2. Now Q2, on encountering A, it goes to the state even A, even A, odd B, which is state number Q1. So on processing A, it goes to state number 1, and the current symbol is now A. Now from Q1 state, which is even A, odd B, on receiving small a, we go to the state odd A, odd B, which is state number Q2. So we come on to state number Q2. Now on state Q2, on processing B, we go to this state odd A, even B, which is QF state. So we have reached QF state after processing the entire string AB, which is the final state. So we have accepted this state. Okay, you got the concept? Do you like the video? Okay, then if you like the video, then please comment me, and let me also introduce you. Take 1 minute pause. See, I have started online and offline courses classes for you, which is under the name of Abhishek Sir Classes for you, and I will be offering computer science and engineering subjects, assistance, programming labs, and research assistance. You can get assistance money on different programming labs like C programming, C++, Python programming, okay, Fortran, assembly language programming, okay, different languages. Even from these traditional languages, I know some other languages also, and you can have the research assistance also from me. Okay, this is my short profile, and you can reach me at this email ID abhishek47722@gmail.com, and this is my phone number 6398903105, and my address is Hari Hospital, GT Road, Aligarh. So if you are interested, you can reach me at these two platforms. Okay. Thank you.